Welcome to section 2.3, linear functions in slope-intercept form. Okay, here's a joke for you. Name the state that has the most math teachers. The answer is Massachusetts. Our objectives for this lesson is that we're going to graph linear equations, and then we want to be able to write the equations of those lines. Now, in order to do that, we need to start with slope. And slope is should be a familiar concept to us. All right, slope is the vertical change compared to the horizontal change. You may remember it as rise over run. Now, if I'm going to do the vertical change, that's going to be the difference in my y-coordinates. So I just take my two y-coordinates, y2 minus y1. And my run, or my horizontal change, is going to be x2 minus x1. Now, the letter that denotes slope is m. So if you see an m, a lowercase m, we're referring to slope. All right, now let's talk about slope on a graph. If you have a positive slope, what that means is that your line is going to be increasing from left to right. If you have a negative slope, your line decreases from left to right. Zero slopes are those with horizontal lines, or all horizontal lines have zero slopes. Because, and the easiest way to remember this is your rise is zero. Between any 2 points, you're not going up at all, you're only going zero. And then a slope that's undefined must be divisible by zero, so that means your horizontal is not moving. Therefore, vertical lines have undefined slope. All right, example 1. Find the slope between -3, 7 and the point -2, 4. Well, the first thing I would like you to get in the habit of is to label your points. So this is my first point. I'm going to use a subscript of 1, x1, y1. And since this is my second point, I'm going to use subscripts of 2, x2, y2. Now, if you remember our formula, slope is rise over run, or y2 minus y1, which is our rise. We're going to compare that to x2 minus x1, which is the run. So if I'm going to find the slope between these 2 points, I start at y2, so it becomes 4 minus 7. And then my denominator is going to be x2 minus x1. So -2 minus -3. So we have -2 in the numerator. -2 minus a -3 becomes -2 plus 3. So I get a 1. My slope then is a negative slope. That means I go down 2 and right 1. Example 2. Find the slope between 9, 3 and 9, -4. Well, if you notice here, we have the same x-coordinate. So does that mean we're not going to have any change in the rise, or are we not going to have a change in the run? Let's find out. -4 minus 3 divided by 9 minus 9. So I have -7 in the numerator over 0. We cannot divide by 0. Therefore, our slope is undefined. Now, if you think about this graphically, you're at 9, 3, which is over here, and 9, -4 is down there. This is a vertical line, and all vertical lines are undefined, have undefined slopes. I want you to do example 3. Find the slope between the points 2, 2 and -2, -2. Now we're going to talk about intercepts, and there are two different types of intercepts. You have your x-intercept and you have your y-intercept. The x-intercept is simply, it's the point where the graph crosses the x-axis. So graphically, that would be right here. All right? And any point along the x-axis will always have a y-coordinate of 0. So if you're going to find the x-intercept, then you need to plug 0 in for y, or substitute 0 for y, into the equation, or the function, and then you solve for x. Now to talk about the y-intercept, that's going to be the point where the graph crosses the y-axis. So visually, or graphically, it's talking about that point right there. And any point along the y-axis will always have an x-coordinate of 0. So if you're going to find the y-intercept, you plug 0 for x into the equation and solve for y. So on our example on our graph, this graph right here has a x-intercept of -2. So that also is the point -2, 0. And then the y-intercept is +3. And as a point, that would be the 0, 3. Okay, so all of this is leading up to us being able to graph lines, which we have already done for several years now. So this next form should look very familiar to you. It's a slope-intercept form. Y equals mx plus b, where m represents the slope of the equation, or the slope of the line, and b represents the y-intercept. Example 4. Find the slope and the y-intercept of the line y equals 4x minus 5. So m is 4, and b is -5. You need to remember that the slope is always going to be the coefficient of x, and the y-intercept is always your constant. Now you do not write 4x when you're talking about the slope. It's just the number. Number 5. Write the equation of the line in slope-intercept form if you know slope and the y-intercept. So the slope-intercept form is y equals mx plus b, and they tell us all of our information already. This becomes just a simple substitution problem. We're going to plug 1/3 for m, and we use 8 for b, because that is my y-intercept. Example 6 is going to be done the same way example 5 was, except instead of them telling us what our information is, we're going to use a graph to find it. So this is a graph that they're referring to, and we want to know what is the slope in this graph. Well, to find the slope, you simply need 2 points, and I'm going to use my intercepts. I can use the points into the slope formula, but there's really no need. If you have a graph, you can just count the rise to run. So the rise would be 1, 2, 3, and then I run 1, 2. So my slope is a positive 3 and a positive 2. 3 over 2. Now you need your y-intercept, which luckily for us, this graph passes through the y-intercept at a nice integer value. So you should be able to count the y-intercept is 3. All right, I have my equation or my information. Now I need to just substitute that into my formula. So this is going to be y equals 3 halves x plus 3. Now number 7 is going to take it another step further. It says write the equation in slope-intercept form. We have 3x plus 2y equals 18. So the form that they're giving us, that is called standard form. And we want to use slope-intercept form. Slope-intercept form is solved for y. So you need to take this equation here and solve it for y. So the first thing we do is subtract the 3x. So I have 2y equals 18 minus 3x. One more step. I now need to get rid of my 2. So I have to divide every term by 2. (18) divided by 2 is 9. Now 3 divided by 2 is not going to be even, so we just leave it as 3 halves. Okay, now what is my slope? If you said 9, you would not be correct. Slope is always a coefficient of x. So this right here is really my slope, negative 3 halves. The constant term in your equation, the 9, that's our y-intercept. Okay, so hopefully you're still with me here. Now these next 3 examples, I want you to complete them on your own. And if you have any questions, just come see me, preferably at the beginning of class, and we can go over them. All right, good luck. But let me tell you, for numbers 9 and 10, you need to put those in slope-intercept form. We don't graph in standard form. Good luck.